Object-oriented programming is a programming paradigm which emphasizes the concept of objects and data and their behavior, so the interactions between them. For example, as you can see here, we have a dog, which is defined as a class dog, and the dog can also be an instance. So when we generate an instance of that dog, we generate an object of that class dog. As you can see below here, we have attributes, for example, height, weight, and food, and we have methods, run, play, eat. So you can think of attributes as data belonging to the class and methods as functions that belong to the same class. What you see here are the 4 pillars of object-oriented programming, also known as OOP. First one on the top left is encapsulation, then we have abstraction, inheritance, and polymorphism. I'm not going into the details of what they are right now because I want to do with you an example. We'll write some code to better understand all of these 4 concepts one by one. Okay, first of all, back to our project. I want to create a new folder into our scripts folder. So right click, create folder, and I'm gonna call it OOP. Inside that folder, let's create a new C# script, which I'm gonna call base class, and open Visual Studio. Okay, this class, I call it base on purpose because what I want to show you is that we are going to implement the first pillar, which is inheritance, and by doing so, I'm going to go back to our Unity editor, and in here, I'm going to create another class, which I'm going to call child class. And let's open this up too. Here we go. Now we have our 2 classes here. Okay, so derivation happens here. What does it mean, derive from a class? Well, that means we have a parent class, like this base class, and we have a child class, which will be the child. So in this case, as you can see, this colon symbol right after the class name is inheritance in place, which means thanks to this symbol, a class is deriving from another class. But then you might say, hey, but then we are deriving from monobehavior. Yes, that's correct. All of the Unity classes we create, they are automatically derived from monobehavior. And that's why we are able to place them in the scene as script components. But let's see how we can derive from this class our child class. So here, back to our child class, instead of deriving from monobehavior, we can click and replace this with the so-called base class, the one we just defined. Okay, by doing so, now child class is deriving from base class. So we created a hierarchical structure that includes base and child class. Now what about encapsulation? Let's go back to our base class, and if you take a look at this class, we have a public name here, which is a so-called access modifier or access specifier. Now public is the top level access modifier, which basically allow everything to be accessible from anywhere, okay? Here, let me show you that we have other 3 access specifiers. So we have public, which is the one we already saw, and we can define an integer variable with that. So public int my public int is equal to, let's say, 0. Then we have a protected int my protected int equal 1. Then we have a private int my private int equal 2. And then we have an internal int my internal int equals 3. But what does these access modifiers mean? So let's take a look at that. Public, we said it's accessible from anywhere. So for example, if I go to my child class and I try to access that field, my public int, so here I can go in start and say my public int plus plus, which is simply going to increment the value. And you see that it's possible, I get no compilation errors. Let's take a look at protected. Now protected means accessible only by the same class and its children. What does it mean? It means that we can access that from here, of course, but we can also access that from child class because we are deriving from base class. So here we can say my protected int plus plus, and that works. We get no compilation errors. If we go back, we have a private int. Now, private is the least level of access, only accessible inside the same class context. Which means I can go here in the same class and say my private int plus plus, and that's okay, no problems. But if I go and try to change that value in the child class, so if I try to do my private int plus plus, from here it's not possible because the access level is too low. I can't access that field from the child class. So the only thing that I can do is to comment this out to allow the compiler to compile the solution. What about internal? Internal means accessible within the same assembly solution. What is an assembly solution? If you take a look at the right, this is your Visual Studio assembly solution, which is basically our collection of scripts and references. Now, that means that if you assign a variable or a method or a class, whatever, as internal, you can access that from anything which belongs to the same assembly solution. In this case, for example, our two classes, base class and child class, they both belong to the same assembly solution. So it's possible for me to go here and say my internal int plus plus. That's okay, it works. It's worth noticing that access modifiers are not only related to fields, like in this case, variables. It's also possible to do something like this. Let me define a new method here, like public void my public method, and another method below here, private void my private method. Now, if I try to use these two methods to call these two functions, I can do it from this class, of course, because even at the least private access, that will work. But if I go to the child class and try to do this, I can do my public method and call that function, but I'm not allowed to do this. This will not work because, for the same reason as above, this is signed as private, and so we don't have access to this method here. Comment this line in order to compile. What about abstraction? Now, to show you abstraction, let's go back to the Unity editor real quick. And what I'm gonna do, I'm going to create a third script here, which I'm going to call main. And since I want this main script to be placed in my scene, I'm going to create a new empty object. So I right click in the hierarchy, create empty, and I call it main. Let me reset the transform on the right click reset, and I'm gonna place this main script right onto my main. Okay, so now whenever I press play, this main script is enabled and will run as we saw in the last tutorial. And so now let's go back to Visual Studio. If you forgot to open a script, you can do it from here. You expand your solution, your script solution here, and you just double click on the script that you want to open, and this opens up here. So what I want to do, I want to try to create a so-called instance object of each of the classes that I created. So I have a base class, bs, equal to new base class object, and then I have a child class, cs, equal to new child class object. So this is a so-called object or instance of that class. Now, to show you abstraction, let me do and make a change to the base class. And before here, before public, I'm gonna add abstract as a keyword, which is going to make this class abstract. What does it mean? Well, that means that this class now can be defined in an abstract way, but I'm not allowed to create actual objects, so instances, out of that class. And as you see, as soon as I change this to be abstract, I got an error here, a compiler error, which tells me that I'm not allowed to create objects of type base class. Though I'm still able to create objects of type child class. So only thing left is to comment this line to make the compiler work. The abstract definition is not only limited to classes. For example, let me go back to base class. What I can do, now that this class is abstract, I can also have abstract methods. For example, I can say public abstract void my abstract method. And this method cannot be defined like this. You see, I get an error if I do this. I need to get rid of the curly brackets and only close it, which means I'm declaring it, but I will need to implement it in any deriving object. For example, if I go back to child class, I can go here and say, okay, now I can do public override void my abstract method, and you see that the compiler automatically fills up what's missing. Now, let me get rid of this, but as you can see, I'm overriding the implementation of my abstract method in the base class. Abstraction also comes in other forms, for example, using interfaces, but that's another story and we will talk about that later. So we covered so far inheritance by deriving from other classes. We covered encapsulation, like in this example, having public, protected, internal, private, and we cover abstraction. Now, what about polymorphism? Polymorphism comes in two ways. One is so-called static polymorphism or compile time polymorphism, and the other one is runtime polymorphism or dynamic polymorphism. I'm going to show you the static polymorphism, which is the easiest one, and then we'll move to the dynamic polymorphism. So for the static polymorphism, let me go back to base class, and below here, I'm going to define two other methods, which I'm going to call public void my static polymorphism method, and I want to do the same thing, so I'm going to copy and paste this, and if I do so, the compiler is complaining about the fact that I have two methods with the same signature. What is a method signature? Well, a method signature is the name of the method plus its parameters list. And you see that that is a unique identifier. So if I have the exact same name with the same case letters, it's a problem. But what I can do, thanks to static polymorphism, I can go here and add another parameter, for example, integer a to my method, which means I will call this function with potentially 0 parameters, like in this case, or 1 parameter, like in this case. And so that means the signature of the method, it's different. For the compiler, these are two totally different things, even though for us as developers, they have the same name. And this is the so-called static polymorphism in place. Now to show that to you, let me just do a debug.log, which is going to log something to the console. So let's do debug.log my static polymorphism base class method. And I'm gonna copy and paste that over here, but I do plus parameter plus a. So it's gonna do the same thing. It's gonna print out on the console this debug log, but in this case, I'm gonna print the a variable too. So let's try to call this from the main. So let me go to the main, and here I have a child class which I can use, because don't forget that even though the base class is not an object, I cannot instantiate the base class. These two methods are public, and so they are inherited here in the child class, and so I can call them from the child class. So here I can do cs.my static polymorphism method, and I can do the same. So cs.my static polymorphism method with an integer a, for example, let's say 5, and these two functions will work because I can call them. So let's save this code. Let me go back to the editor. Here we go. So I'm ready to run it because I already placed the main script onto the main object, but I don't see any console here. So how can I access the console? I can go on Window, General, Console. Let me ping the console over here, close to the scene view. And this is where I will see all the debug log messages and all that stuff. So let me play. And here we go. Magically, I should see these two messages. My static polymorphism based class method and my static polymorphism based class method plus parameter 5. If you double click on any of these lines, you see where they come from. Let's go back to Unity and stop our game. And now it's time to show you dynamic polymorphism in place. Let's go back to Visual Studio. Now to show you dynamic polymorphism, it's a little trickier because what I need to do is to define another method. So let's say here dynamic polymorphism. And what I want to do, I want to set up a new method. So let's say public virtual void my dynamic polymorphism method. And what I'm going to do, I'm going to copy and paste any of this line, debug log, and what I'm changing is just my dynamic polymorphism base class method. Whenever I call this method, I will see this debug log on the console. Now let me go to the child class, because you notice that I use this virtual keyword. What that is that it's specifying that this method will be registered onto the virtual table, which basically tells at runtime the program, which doesn't know at compile time who is calling what, so what object is calling what kind of method, but this virtual keyword is designed with a purpose, and the purpose is that I can go to the child class. Let me copy this. Back to my child class, I go here, paste, and what I can do public override void my dynamic polymorphism method, but right now I'm overriding that method by being called by the child class. So let me change this debug log to be, instead of base, it's gonna be child class method. So right now, if I call this method from the child class, this will be my dynamic polymorphism child class. If I call it at the base class level, this will be my dynamic polymorphism base class method. But let me show you one thing. If I go back to main, right here, I can do this. I can do game object, which is the base game object Unity class, GO, is equal to new game object. And this will generate a new game object and place it on the scene at runtime. What I can do go.add component of type child class. So far, so good. And then if I go and say go.get component base class, which is totally possible because as we know child class is deriving from base class, I can do dot my dynamic polymorphism method. You might think that I'm calling the base class method, even though since this component was defined as a child class, so the lowest hierarchy level was defined to be the child class, even though I'm calling the base class method here, I will actually call, thanks to the virtual keyword, the child class level method. And to show that to you, let me just save, go back to Unity, compile, and run it. As you see, I see in the console my dynamic polymorphism child class method here, even though I thought I call it from the base class level. Let's stop the game. So these were the 4 pillars of object-oriented programming, which is a very well-known programming paradigm that is super useful, especially when it comes to game dev, and we'll see that in the future. So if you guys enjoyed this video, don't forget to subscribe, like, and share, and I'll see you at the next one.